Welcome to you from Chem Help ASAP. This reaction video is going to look at a video from a channel called Extractions&Ire. And this is a channel I wasn't familiar with, but it has some great chemistry in it, specifically organic chemistry, and that's important because that's my area of expertise. So let's go ahead and take a look at this video.
Alright, here we are again, it's vaguely sunny. I was promised that it wouldn't rain today, but I still don't trust it, so we're going to go undercover here. I'm going to try and rush through today because it's winter solstice pretty much, so it's like the shortest day of the year. So we don't have much longer.
So it's winter solstice. He's creating this content in Australia, and in Australia the winter solstice is actually June 21st instead of December 21st. So he's that's different from where I am, which is in the northern hemisphere, since he's in the southern hemisphere.
Right, and as per usual, I tend to run out of light even on long summer days. So on winter solstice, I'm pretty much guaranteed to be working in blackness before long.
Let's go back to that table. That table, see, it's kind of flexing in the middle. I think I own that same table. I have a plastic table that's doing exactly that. At the hinge, it kind of bends a little bit. So anyway, I feel your pain.
On winter solstice, I'm pretty much guaranteed to be working in blackness before long. Today we're trying to make cyclohexanone. No, we're not. Cyclopentanone, yeah. Look, we're rushing and I'm getting things wrong. And this is going to be the start of another very long organic synthesis project, which I tend to start and haven't really completed too many of them. And this one looks especially long, and I probably won't finish it until I retire in 86 years. But I thought this video would still be interesting in isolation, so I'm not going to introduce the project. We're just going to do this synthesis. Hopefully this end product of the cyclopentanone will keep for a long time. It looks like it's not that volatile, so it should keep for a long enough time for us to then get around to doing the next step.
That's an important point. When you make things in organic chemistry or any synthetic chemistry, when you make something that you want to use later, it needs to be stable enough to stick around until you want to use it. And not all compounds do. So, in this case, he feels like it has good stability. But there are times when you make something knowing that once you make it, you're going to use it almost immediately, because otherwise it may not last on the shelf or in the presence of air or that sort of thing.
So how are we making the cyclopentanone? Well, we have here some magnesium stearate.
How the F is he going to use magnesium stearate to make cyclopentanone?
And you might be asking, how the fuck is he turning magnesium stearate into cyclopentanone? That is a very good question. I have no idea how the fuck we're going to turn magnesium stearate into cyclopentanone. I didn't even order magnesium stearate. Pretty much the only chemical that I've ordered in the last month or so has been adipic acid. So this must be adipic acid. Well, this is my adipic acid order shipment. So they've either labeled it magnesium stearate just to get around customs or something, or they've just sent me the wrong chemical, which either of them is probably just as likely. So first thing we have to do is actually open our package and see if it's actually the chemical we think it is before we can even start anything else. All right, that was the least exciting reveal ever. We've just got a package.
It might be hard to see there, but that package does say adipic acid. So it apparently is the right stuff.
Inside the package it says adipic acid. I assume that magnesium stearate, I think it's a food or a soap preservative, so it just clears customs easier than putting a dip.
Now I'm going to pause him here. He is opening this up, and if you notice to the right, he has that is a strip of pH paper. So he doesn't explicitly say what's happening here, but I think he's actually doing a test to make sure that, because the package says magnesium stearate in one place and adipic acid in another, and he wants to make sure it's adipic acid. So he's going to touch a sample of that solid to the pH paper and see if it gives a acidic indication, if it gives a reddish color, and that'll confirm that the adipic acid is actually adipic acid and not magnesium stearate.
Adipic acid, they probably would investigate the package more than just having a soap material, so it's just a scam to... Well, is it a scam? I don't know.
Now that's not a super great result, but there is a little pinkish to that pH paper, so I think that's enough to put aside his fears. This almost certainly is adipic acid and is not magnesium stearate.
It's a scam that helps me out. Thanks, China, for helping my parcels clear customs. You do feel bad for a lot of suppliers from locally in Australia that really have to follow these rules exactly. Otherwise, they get big fines. Very hard to compete with people who do stuff like this.
So, welcome to global commerce. Customs are a reality. It's a real problem.
This is a catalytic decarboxylation. I'm fairly sure those are the correct words. And we're following a synthesis from Tom's lab, which, if you don't know Tom's lab, is a very good channel. Very nice organic synthesis like this. So
I don't know Tom's lab. I have since checked on his channel. It doesn't look to me like he's actively producing content, but I will put a link to Tom's lab's channel in the video description.
Link him in the description so you can check out Tom's lab channel. And we're going to be following it pretty much exactly, I believe. I mean, why not? It worked well for him, so maybe it will work well for us.
So here's the overall scheme. This has adipic acid on the left. The molecule contains 6 carbons. He's then redrawn this structure to show how the molecule can wrap around on itself so one end can react with the other. And through the process of this reaction, we're going to lose water. And that'll figure prominently in the rest of the discussion. So remember, we are forming water in this reaction. And it also undergoes a decarboxylation. We go from 6 carbons to 5 carbons, so I have to lose a carbon somewhere, and here we lose it as CO2.
And for that we need barium hydroxide. And I'm fairly sure I have barium hydroxide. Should be somewhere around either... Oh, where did I... Oxides? No. Oh, there it is. Look at that. Bases sort of covered. Look at me go. I just like flexing that I can actually locate things. Tom's lab does a 100-gram scale. We're going to do a 200-gram scale.
200-gram scale. That is big time. So that's pretty bold. First time running a reaction going 200 grams. Go big or go home.
So he does 100 grams of adipic acid and 5 grams of barium hydroxide. I like how I'm saying he does this, he does this. So if everything goes wrong, I can just be like, it was Tom's lab, he did it. As if I somehow lack the ability to double check things. Anyway, whatever. 200 grams of adipic acid and 10 grams of barium hydroxide. I think I've got enough of that. Yep, that's fine. Don't touch the poisons without the gloves.
Okay, I'm going to mute him because he has some music that overlays. Here he's weighing things out. He's weighing that in a plastic cup. I like that because a plastic cup is, it doesn't look that fancy or that scientific. But the fact is, if I were going to do this in my lab, which is a pretty nice lab, I'd probably weigh this product in a weigh boat. Well, what is a weigh boat? But it's basically a plastic cup. So this is perfect. Now, notice how he's doing this. I'm going to pause. He's holding this bag of material. This is his barium hydroxide catalyst. And so he doesn't want too much of it. So he's holding this with his left hand, and he's holding it still. And then with his right hand, he's tapping on his left hand to cause it to shake and jiggle out some material. It's hard to do this with one hand and just jiggle gently enough that you don't dump in gobs of stuff. So he taps with his right hand, and I suspect he's right-handed. So he's holding it still with his offhand and then tapping with his right to get it up to the amount that he wants, but not too much. Great technique. Mixing everything together, that's a nice funnel, and I think we can bring back the audio here.
Start heating. There's some water coming off around the top here, and that's what we expect. We expect a bit of water.
Okay, I'm going to pause. That's a great look at it, at his reaction setup. So he has all of his solids combined in a round bottom flask on the left, and they're in a heating mantle. He said apparently he's already heating it because he said there's some water forming. So the reaction is already going, even though everything's still in a solid state. And you can maybe see a little haziness on the top of that flask on the left. That would be water condensing on that glassware. He then heats that material up. Whatever is volatile is going to go up into the glassware and it's going to cross over to the right, and it's going to hit the condenser, which will be cooled, and then that will condense any vapors and they will drip into his receiver flask on the left. So this looks perfect.
Water to come off. I might change that flask later on, but we're going to have to redistill, which is why I've got no nice head here. It's just that corner piece and no temperature control. We'll work that out. Hold on, I should turn on that condenser water. I need this one there. So this will probably need heating for a little. So
he's heating. He's now adding. He has the condenser being filled with cooling water. Note that his condenser water is kind of blue or green, and that's likely copper sulfate. He's added that likely to the water bath or the water reservoir, and that will help suppress the growth of any unwanted biological organisms, any fungi and stuff. So that's just to keep that water relatively clean with the copper sulfate or copper salt.
Wow, quite a few hours potentially. The big concern is we don't want to sublime off too much adipic acid. We don't want it to clog, but we also don't want it to come over. If it's starting to come over, I can change this out for a different head, but I've just put this head in here for efficiency. It's just a corner piece so we don't lose any heat or have any reflux going on. We should just have our product just coming over. It'll probably be a little bit more contaminated than if I was using a nice head. Once again, we are redistilling it, so I'm going for efficiency here. We're fucking...
So this is a risk, and he knows, and so he's aware there's a risk. He's going to get some of that adipic acid to get into his condenser, and it could plug up things. So that's a little foreshadowing of what we might see in the future here.
Speed running this synthesis safely. All the adipic acid has melted, which of course it has because it has a melting point of 152. Let it go for a little while. Hopefully, the stuff coming over is water, not adipic acid. Although it's getting a little cloudy here, so. Fuck it. It should be all right.
Okay, so everything's heating. Everything has melted together. It's a great thing about if you have low melting compounds, you can sometimes not use a solvent to get things to mix together. You just melt them together into a liquid. And that's exactly what he's done here. He hasn't added any solvent. This is just his molten material. And he does have some water going up that condenser, or something is condensing in that condenser. Presumably it is water, which we know should be a byproduct in the reaction.
It doesn't seem to be boiling very nicely, so I might chuck some fucking boiling stones in there, like rocks or something, just to help that boil, because it doesn't look like looks like it's on the verge of bumping. Okay, usually I blame the chemistry for going yellow, but this time it was definitely me. It was a perfectly clear melt until I added some literal rocks into it, and then it turned yellow. So the yellow here is due to me adding some rocks. But
so what he's done is, when you heat things, if they get super heated, sometimes things will bump. And so by putting a boiling chip or a boiling stone or boiling rocks, that creates a jagged surface where you can form gas bubbles, and that helps things to boil more smoothly. You get a rolling boil instead of a vigorous kind of burping action. So they call it bumping. So that's what he's done. And, there might have been something on one of the boiling chips and it gave a little color. And not a problem at all. He's totally right. It doesn't look as pretty, but everything's going just fine. Notice that as he was taking apart the apparatus, he probably had to turn the flask around a little bit, and that allowed some of this molten adipic acid to get on the top of the flask. And so it hit the cold flask and it froze. And so he does have some solid up there. That'll all sort itself out. That's not a problem. Everything's looking great for this reaction.
Shouldn't affect it. The yellow shouldn't come over. The yellow shouldn't spread, although it probably will, knowing me.
Okay, so now I have to mute him because we're going to do some music here. I do want you to catch this shot. Notice he's got a great reflection in the middle of that flask, and he's going to wave to us through that reflection. Or a thumbs up. That's great. Great directorship right there. So he's playing music. I'm going to talk over this. Everything looks pretty normal. He did a little talking there. Notice that it kind of pops. So that's a little bit of a problem. So what he thinks is happening is water droplets are forming and going up and then dripping back down. And when they drip down and hit that really hot molten material, they just kind of erupt. So he doesn't like that because, of course, he doesn't want anything else to go into his distillation setup. So he's going to try to fix that a little bit. One thing that will help is that likely in this reaction, the first thing to form is the water. So if you can get past this rough spot with the water, hopefully everything will smooth out a little bit. And so what he does is he wraps this up in foil, and the foil is meant to kind of keep a more uniform heat. He mentions it also covers it up if it's misbehaving. When I was a graduate student, I used to love to wrap things in foil, things that I was heating. And then one of my lab mates came by and said, "Are you trying to keep the heat in, or are you trying to conduct the heat away?" And yeah, that's a pretty good point. So after that, in between the foil and the glass, I would put some cotton or maybe some glass wool, depending on the temperature of it. And that helped give an insulation barrier between the flask and the foil. But foil is very convenient. You have it in almost every lab. And it's cheap, it's disposable, and it's form-fitting. So whatever your setup, you can always just kind of mush the foil around it, and bam, you have an instant extra layer of cover. Okay, so this looks good. It does look like he's getting some solid in there, but that's okay. He just got to roll with it. YOLO is kind of what he's saying here. Okay. And it's cooking. Looking good. There is certainly some solid forming in the top there, and he's just hopeful that it won't get out of control, but he was worried about it, and it came up, but you can't start over. We just got to run with it. He's collecting something, distilling over. That's encouraging. It's no longer erupting like it was, so hopefully the water issue has subsided. That looks really good. That looks great. Okay, it's getting towards the end. He's dripping. I think we can now listen.
Love and care it deserves. Went and spewed some acid over. Well, I think it's just been subliming it over, but the pot temperature probably got a little hot. It's a little bit threatening how close this is to clogging. I probably should do something about it. Lord, oh Lord, that's a narrow point with a lot of bloody acid forced into it. So, there's a saying we have in chemistry. She'll be right.
She'll be right. I've never heard that saying, but once you get deep into a reaction, you're not going to start over. You've just got to see what you're going to get. And of course, sometimes what you find out is you get a failed reaction, but at least maybe you learn something by following it to the end to learn something better, what not to do next time. So he can't turn back now. He's got to go. And I need to mute again for a little bit. Giving things a wiggle. It's going. He's going to have a nice shot right here in a second. Look, he's got liquid coming over. Yes, there's a lot of solid, but that liquid is getting past. It is what it is. That's just about it. Okay, now we're going to talk again. Let's hear.
Actual product. It looks all good. All that's left in the flask here is a little bit of tar and delicious barium hydroxide, so that's looking great. I mean, that's great. That's an achievement in of itself, but really the real miracle is it's still daylight. We still have like half an hour of sunlight left, so I might actually even pack this up without it going dark. Have I improved? Have I learnt from my mistakes? Look, it's looking like it, although it's more likely to be just pure luck. Thank you, Tom's Lab. I haven't finished yet. I still have potential.
So he didn't blame Tom's Lab. He thanked Tom's Lab. So very well done.
To crack everything and drop everything in the ground. So I won't make too much grand statements yet. We didn't clog it, although we came threateningly close. So there's some lost yield here with all the acid that came over. But hey, look, we're not taking away from the fact that we've sped run this enough that I don't have to pack this up in the middle of the night. So hey, I'm taking my achievements where I can bloody well get them. So I've got two fractions here, and I say fractions, but that implies that I had some sort of temperature control, and I didn't. I just thought I was having water over at the front here, and I just thought I'd switch out the flask, but on closer inspection, it looks like it's mostly cyclopentanone with a little...
So he did take two fractions. He collected some of the liquid that came over early, and then put a fresh flask in and collected the later material that came over. He was thinking that would be mostly water, but it probably wasn't. This is a good precaution. Just in case you want to keep things separate, get them separated. Because it's easier to keep them separate when you separate them early than to try to separate them later. It turns out it wasn't necessary, but that's good defensive chemistry.
A little bit of water at the bottom, which is collecting all that powdered acid. I will combine these two, and then we'll have to do a lot of chemical cleanup and then a redistillation.
Okay, we're going to combine the two, then we'll do some chemical cleanup. I want to refer back to that, and then a distillation. So he has obtained his material from this reaction. Now, I wouldn't say this is really the isolated product. You could call it that, but his chemical cleanup is something called a workup. And a workup is a final step you do at the end of a reaction to get your isolated material, your crude material. So he's going to do some transformations on this, nothing exotic, but some simple things to try to get rid of impurities. What impurities? Well, he may have water in there. He wants to get rid of water if he can. And he thinks he's got strong indication he has some adipic acid in there. He wants to get rid of that as he can. And then that will give him his crude isolated product. Now, once he has that, he still has to purify his crude product, and that will be the distillation step. So the next steps we're going to see are all something that's called a workup.
But hey, I can stop now and actually I've gone on about this too much, right? We get it, Tom. You managed to do one simple distillation in one day, all right? We get it, okay? Calm the fuck down. Here we are the next day, and we've got a lot of acid crystallizing out here, which is fine. I mean, it's all lost yield. I wouldn't be surprised if all the water's been kind of sucked into that adipic acid there. Wow, this sunbeam coming through is really bad. Winter is really not the best time for me to film for several issues. I mean, it gets wet.
I like this wide shot of some of his lab workspace. You can see he has other things going on. So he's showing us this reaction, but clearly he's dabbling in other things as well.
Wet, there's less sun, you know, it rains, it gets dark. But definitely the sun lining up with the entranceway of this door here. And even if I shut that door, then it leaves that gap at the top there. Makes it bad for filming these sunbeams all the way through. In summer, it doesn't line up so bad, so it doesn't like perfectly shine on these things. But anyway, sorry, I'm just griping about winter a lot in this video. There's still probably a lot of acid dissolved in here, so I'm just going to have to do a base wash here in the separatory funnel and then dry it somewhat before our distillation. We really want to get as much acid out as we can chemically so that none of it comes over in the distillation. Right, I added some distilled water just to wash out some of...
And this is all part of the workup. He's doing a little transformation on this to try to get his isolated material as crude as clean as possible.
The acid initially, and it's all formed one nice clean layer. So we either have everything that we've distilled over and collected is water, which would be a very big disappointment and also very surprising. And the other option, which is far more likely, is that the water's just dissolving in the cyclopentanone. I'm just forgetting the name of the compound every time that we're making. The water's dissolving in the cyclopentanone along with all the acid and everything like that. It's all just dissolving into one mix. So I've got some sodium.
So in adding water, he hoped that the relatively nonpolar cyclopentanone would not mix with the water and it'd form a distinct layer. But unfortunately, with all the other stuff in there, everything's mixing together. So it just didn't work out. He has a homogeneous layer. He now has to do something to force his cyclopentanone to not want to mix with everything and form its own layer. And so we're going to see he's going to add sodium carbonate.
Carbonate here, and adding it should neutralize the acid but also force that water layer out.
So I'm going to mute him again because this is going to have music, but he's adding sodium carbonate that's a base. It will react with any acids that are present, like adipic acid, which he thinks is in there. And so as that neutralization occurs, it's also going to increase the ion strength of the water that's in there, his main solvent. And hopefully, if the ion strength increases enough, then that cyclopentanone will be forced to form its own layer. It will no longer be miscible with the aqueous layer, and presumably the cyclopentanone will be less dense and will float on top. So let's see how this works out. So this is reacting. The sodium carbonate's reacting with the acid, and it forms CO2, and he's seeing that CO2. It looks like there's droplets in there. That's a good sign that something's separating. So he's letting that react and giving it time. That looks like it's two phases forming. Looking good. He is talking, but he's got this music going too. So he's got to let this sit for some time. There's the layer forming. One thing he says is he's going to go get a cheese toasty. So he took a little break to let this material separate out. So I'm going to keep this muted for a second because he's going to come back and see he has layers. He's going to drain off that bottom layer. That's the aqueous layer that contains the salts of adipic acid, That's all stuff that he doesn't want. So he's done a chemical process to remove some of these impurities. And he's going to do a little more just in case all the acid isn't gone. He'll throw in some more carbonate. And now I think we're ready to listen.
A neutralizing solution, there's just a lot of acid. So much so that there's probably worth recovering that sodium adipate from that solution. Then we can regenerate it back to adipic acid and add it to the 300 grams we have left over. And I'm just going to run this through a simple distillation.
Okay, so I'm going to run this through a simple distillation, he says. So that material in that separatory funnel, that is now his crude isolated product. He's done with these chemical processes. Now he has this as clean as he thinks he can get it, still a crude product. And how is he going to purify it? Do a distillation, so he's going to distill his product and separate the cyclopentanone from other components that have a very different boiling point. That's why he gives us the boiling point on the screen.
If there's any acid left, well, there might even still be some acid left, that should stay in the pot because the pot temperature doesn't have to get too hot now because we only have to boil over the cyclopentanone.
Okay, I have to stop him because he's going to play music. But now here's his setup. Let's go back to that. Play just a bit. So here's his distillation setup. He has the heating mantle now on the right, and his flask is hidden inside that heating mantle. That's a big plastic jacketed thing. You see the lights on. It's heating up. There's also a stir bar in there, I'm sure. And he's heating that into a still head. He's monitoring the temperature in that still head. Any vapors then go down that jacketed condenser, and then he will collect in the receiver on the left. And in this screen, he has a beaker as his receiver. So that's his setup, and he's going to do a distillation. And he also has a temperature. It's hard to see. It's a little bit in shadows, but there is a thermometer where he can monitor the temperature at the vapor interface at the top of that still head. Okay, so we're going. There's the stir bar going. It's heating. He's getting vapor up there. It's condensing and dripping into his receiver flask. Right now it's a beaker. He's waiting until the temperature rises up to the boiling point of his cyclopentanone. That's like 128, I think he said. Now, if you notice, his receiver flask has changed from that beaker. That beaker is a little bit to the left, but underneath his distillation apparatus now is it's a flat bottom flask, but it's kind of a round bottom flask. That has 200 written on it. I'm almost certain that is his tare weight for this flask. So he's going to collect his desired cyclopentanone in that flask, and then he can just weigh the whole thing at the end and subtract away 200 grams, and that'll give him his mass recovery from this process. But he's got to collect his material first. So he's heating, monitoring the temperature. I think it's at 126 in the background. He likes what he sees. It's still collecting. That's a good temperature. Okay, I think we can unmute.
We've got as much as we can get out of there because it's getting really ugly there in the boiling flask, and it's making my product turn ever so slightly yellow. You can even see a little bit of...
It is getting just a little yellow tinge, and that's because that yellow color it's just splashing up into the distillation head. So it's time to put this distillation to rest.
The gradient, see at the top there, it's a little bit yellow, so it's just starting to yellow up and tar up and come over and contaminate my beautiful product. Yeah, there's fuck all.
It is beautiful. Really nice distillation.
Yeah, right. Yeah, no, that's cool. Product looks good, so no complaints. Let's just weigh it, determine a yield, and everybody gets to go home. All right, so there's 54.8 grams, and that's, I don't actually know what the percentage yield of that is, but I say it's kind of okay-ish. I don't know.
Okay-ish. I think that's really good. Remember, he did this as a speed run. He was going as quickly as he could. He still got over 50 grams of material. That's a lot of compound. This is a very large-scale process. 50% yield. Yeah, I'd say I'd be totally satisfied with that.
Where we lost a lot of the stuff, I think we did lose a bit of stuff in the neutralization. We lost a little bit of the distillation here. A lot of it came over with the water.
You lost a little bit. He's now reflecting, like going through his mind as a good chemist does. If I were going to do this again, what might I do differently? What should I look for now that I know how this process goes? So he's just kind of debriefing himself on camera to see what's going on. Now, the one thing I will say, we see the product and it looks good, but things that look good aren't always pure. So, it's just because it looks nice doesn't mean it's a great product. But everything is very encouraging at this point.
Should have used my bloody fancier head with a fractionating column a little bit inbuilt. Would have had that separation between the water and the cyclopentanone.
Yeah, he's not bad. He's just, he's just now thinking, if I do this again, how am I going to improve this process?
Much more distinct. We don't need a particularly dry for our application anyway, so she'll be right. Anyway, we've turned what is basically a food preservative that's easily shipped from overseas into a flammable liquid. Thanks you all for watching, and I'll see you all.
Well, thank you, Extractions&Ire for making this content and sharing it with everybody so we can enjoy it. Thank you for your attention and for watching this way all the way to the end. If there's anything else you'd like to see me cover in a reaction video like this, please let me know. And if it's within my realm of experience, I'd be happy to give it a look. Anyway, I hope you're well and take care.